Hi guys, today we are going to talk about the most fundamental and important concept of algebra, which is vector space. So what is a vector space? It is merely a set of vectors satisfying some specific properties. So you can write a set of vectors, let's name it, because that will help us in the upcoming session. I have given it a name V. Okay, a set of vectors V, and here comes another set, field. Over a field is a set with some specific axioms, and I hope you would be familiar with that because that is in your previous course. So I don't have to discuss that again, although I'm going to name it as F, and a set of vectors over a field F. And obviously not every set of vectors can be regarded as a vector space. Certainly there are some properties, and those properties are actually 9 properties, and so I will write such that it satisfies the following axioms. The following axioms. Okay, so there are 9 axioms, and from axiom 1 to 5 are actually about addition. Okay, let's do it a little bit different. So here from 1 to 5 are about addition, and they say that your V, the set V, must be a vector, must be of an abelian group. And you know, to be an abelian group, it must satisfy 5 properties which you have studied in the group theory, and with respect to addition. Okay, not with respect to addition. And then there comes the next 6 properties, which are certainly about the multiplication, but vector multiplication, not just simple multiplication, because if you say multiplication, then that would be wrong. Here I say vector multiplication, that is it. So I'm going to write those axioms one by one here. So these are 5, 1 to 5. Here they have been discussed. So here comes the 6th one. Okay, here. So the 6th axiom says that okay, one thing that I would like to mention here, that if you talk about a vector space, then the elements of vector space will be said as the vectors, and the elements of this field will be regarded as the scalars, and the scalars have no dimension, they are just the magnitudes. So you can relate the idea of physics. So if the first axiom of the vector, sixth axiom of the vector space says that if you have a scalar belonging from your set F and you have two elements from your they can be more than 2 from your vector space V. And if you multiply a scalar with the sum of those elements of vectors, then it will result, you can multiply by adding those vectors, then you can multiply the scalar, or you can separately multiply scalar with those vectors. And let's see how this thing happens graphically. So if graphically you see that this is a vector and this is your this is another vector, this is V and this is W. If you add those vectors, then here will be your resultant vector, which will be V plus W. And fine. And here, in case of when you multiply alpha with your V plus W, what happens? You actually multiply a number with your vector, and that will do nothing but a change in the length of the vector or in the direction. So this can result in this. And similarly, you can do it by separate multiplication. If you multiply this thing with this, it will result in this thing. And now you can see that this is greater than that, and here it will be like this one. Okay, not this one, this one. Here, if separately multiply alpha with the W, it has increased the length of this vector. And if you find the resultant of them, you will then again get this thing. So this thing is obvious, this thing is true, and can be proven by using the laws of vector addition. So since this is a vector multiplication, so certainly it's about vectors. Similarly, if you have two scalars, sum of two scalars or more than two scalars, and you multiply a vector with them, then you can do that. This is the same thing if you do it separately. If you separately multiply alpha with this vector V and beta with this vector V. Now let's move toward the 8th rule. It says that if you multiply a scalar with the product of a scalar and a vector, then you can multiply a scalar with the product, or you can multiply both scalars and then you can multiply it with a vector. And finally, here comes the 9th rule, which says that if you have if an identity, a unit from your field, belonging to your field F, and then you multiply with the element of vector, either from the right side or from the left side, you will get your vector again. It will make no change in the magnitude of in the length of the vector. And obviously your alpha and beta will belong to the field, and your V and W belongs to your vector space V. This V is greater than the V and W used in the example smaller. So it was vector space.